Hey everybody, thank you for joining me. It's Mrs. Woolley. Today we're going to look at 2.3 expressions with negative and zero exponents. So we're going to complete a do now, some class notes, and practice problems. I've assigned on IXL your homework, and it is in the recommendations from your teacher, F6, understand negative exponents. The number of 5-letter words that can be formed with the English alphabet is 26 to the 5th power. The number of 3-letter words that can be formed is 26 cubed. How many times more 5-letter words can be formed than 3-letter words? Well, this is very important vocabulary. How many times more means what is that factor? And in order to find that out, we need to divide. And so we're going to take 26 to the 5th power, which is the total number of words that can be formed, and divide it by the number of 5-letter words. So right here we have the number of 5-letter words, and we're dividing it by the number of 3-letter words. So we have 26 to the 5th power divided by 26 cubed. And if you remember, when we're dividing and bases are the same, we subtract the exponents. So this is 26 to the 5 minus 3, which is equal to 26 squared. And that's our first answer, which is written in exponent form. Now you need to remember that 26 squared means 26 times 26. So when we multiply that together, we get 676. So 676 more words can be formed. So now we're going to take a look at today's lesson, which is integer exponents, and you want to apply the zero and negative exponent properties to simplify expressions. So any non-zero number raised to the 0 power is 1. So we're going to take a look at these examples. 9 to the 0 power is equal to 1. 4, and we need to remember the operation between the 4 and the x to the 0 power is multiplication. So 4 times x to the 0 power, well, x to the 0 power is 1, and 4 times 1 is 4. We have 3x to the 5th power divided by 2x to the 5th power. So when we're dividing and bases are the same, we subtract the exponents. So now we have 3 times x to the 0 power divided by 2. And x to the 0 power is 1, so our answer is 3/2. We're now going to take a look at the negative exponent property. And we flip and change the sign to positive. So if the negative is in the numerator, we change the exponent to positive and rewrite the base in the denominator. If the negative is in the denominator, we rewrite the exponent positive and the base is now in the numerator. So 4 to the negative 1 power, I'm going to write over 1. I'm going to flip and make the exponent positive. So you need to remember this could be written as 1 times 4 to the negative first power. So this equals 1 divided by 4 to the first power. And last Friday, you actually explored this idea and zero exponents as well in your inquiry activities. So today we're actually using the rule that you explored on your own on Friday. So in example 2, we have 1 divided by 5 to the negative 2 power. So a negative exponent means flip it and make the exponent positive. So this is the same as 1 times 5 squared, which is equal to 5 squared, which I could write as 25 or leave it just like it is. In example 3, x to the negative 3 power Well, if I don't see a denominator, it's 1. And I'm going to flip my negative exponent and make it positive. So again, you need to remember that the coefficient for a variable, if you don't see it, is 1. So this is the same as 1 times x to the negative 3 power. So when I flip my x to the negative 3 power and make the exponent positive, the answer is 1 divided by x to the negative 3 power. And in the last example, 3 divided by 3 to the negative 2 power. Well, I don't see an exponent for the number 3, so it is 1. And that's actually positive. So I'm going to leave it in the numerator. I'm going to now look at the denominator, and 3 to the negative 2 power. I'm going to flip it and change the exponent to positive. So now I have 3 to the first power times 3 squared. And I want to remind you, when bases are the same and you're multiplying, you add the exponents. So this becomes 3 to the 1 plus 2, or 3 cubed. Now we're going to take a look at some practice problems. Express in simplest form without negative and zero exponents. Assume no denominator equals 0. So on example 1, we have the number 1 in the numerator, and the denominator, it's divided by 7 to the negative 2. So I'm going to change positions and make the exponent positive. So this is equal to 1 times 7 squared. And 1 times 7 squared is 7 squared, which is equal to 49. In example 2, the entire parentheses is being raised to the 0 power, and that equals 1. In example 3, I'm going to use the product property. When bases are the same and we're multiplying, we add the exponents. So this is 4 to the negative 5 plus 2, which is equal to 4 to the negative 3rd power. So I have a negative exponent. So my next step is to rewrite this with a denominator of 1. Now I'm going to change position and make the exponent positive. I do need to remember that if I can always add the phantom 1 to the numerator and write this as 1 times 4 to the negative 3 power. And so I could rewrite this as 1 over 4 cubed. I can leave the answer just like that, or I know that 1 over 4 cubed is the same as 1 over 4 times 4 times 4, which is 1/64. Either answer would be absolutely acceptable. On example number 4, we have 5 to the negative 2 power divided by 5 squared. So again, we can use this idea that multiplying by 1 does not change the product. So in the numerator, I have 1 times 5 to the negative 2 power. So I'm going to change position and bring this down, and I have 5 to the positive 2 power. Now you will notice in the denominator, I already had a 5 squared. So I'm going to rewrite that. Now I need to use my product rule, which says when bases are the same, you add the exponents. And I know 5 to the 2 plus 2 is 5 to the 4th power. And that is perfectly fine. That's a great answer. If I want, I can multiply 5 times 5 times 5 times 5. And I actually know that 25 squared is equal to 625. Or 5 to the 4th power is equal to 625. So in example number 5, we need to use our power of a power rule, which means we multiply the exponents. And I always like students to show that operation of multiplication. So 3 times negative 2 is equal to 6 to the negative 6th power. Okay, now I'm going to rewrite this as 1 times 6 to the negative 6th power divided by 1. And I know if I multiply or divide by 1, it's not going to change that product. So I'm going to now take my 6 to the negative 6th power, and I'm going to change position and make that positive. So now I have 1 divided by 1 times 6 to the positive 6th power. And that simplifies to 1 divided by 6 cubed. Okay, in problem number 6, I'm going to bust up my numbers and my variables. So what that means is I'm going to rewrite the first part as 3/9 times x squared divided by x to the negative 3 power. So I can very easily simplify 3/9 because I know that 3 goes into 3 once, and it goes into 9 3 times. So 3/9 I can rewrite as 1/3. Now x squared, that exponent is positive, so I'm going to leave it in the denominator. But the x to the negative 3, right here, I'm going to bring that up, change position, and make the exponent positive. And when bases are the same and I'm multiplying, I add the exponents. So now I have 1/3 x to the 5th power. That was a very challenging problem. It used several of the laws of exponents. So the last thing we're going to look at is to determine whether each equation is true or false. So we have in example number 7, z to the negative 7th power times z squared. And so when I know bases are the same and I'm multiplying, I can add the exponents. So on the left side, I have z to the negative 5th power. On the right side of this equation, I have z to the 7th power times z to the negative 2 power. So again, when I'm multiplying and bases are the same, I can add the exponents. So z to the 7 plus negative 2 is z to the 5th power. Now these are not equivalent because z to the negative 5th power is the same as 1 over z to the 5th power. And z to the 5th power is just z to the 5th power. So I'm going to use a symbol with the equal with the dash through it, which means not equal. So in this case, this would be false because these are not equivalent. So if I look at example number 8, I can apply the quotient rule to the left side because bases are the same, so I can subtract the exponents. So this becomes b to the 5 minus 10, which is b to the negative 5th power. On the right-hand side, I can use my power of a power rule, which says I multiply the exponents. And I know b to the negative 5 times 1 is b to the negative 5th power. And since b to the negative 5th power does equal negative b to the negative 5th power, this statement or equation is true. All right, I want to thank you for working so hard and remind you that the homework you may now start, and it is understanding negative exponents. Thank you so much for watching this video, and I hope it was helpful. Please feel free to ask any questions during class or email me later on. Thank you.